Give me a countdown. All right. Hello, everybody. Welcome to the first Science Sunday of 2024. Hopefully, one of many more to come. Mike and I have been doing this for, I lose count, something like 12 or 13 years. Mike did it for about a year before I joined. Um, this is an interesting forum. Um, Mike and I, and many of our friends gathered today, and many other friends, are members of the Prairie State Humanists, who co sponsors this event. Humanists are convinced that the best way to understand what's real and possible in the world is through science, and that in fact science provides the only mechanism for understanding and winnowing out the truths of the universe. So some of us take scientific discovery and scientific insights very seriously. I've been trying to keep up with scientific discoveries ever since I was in junior high. So it's kind of a lifelong passion of mine. And I know it's a passion of Mike's. Mike was a science teacher at one point. He's not here today. He's a little under the weather. So this was supposed to be his Science Sunday. Mine was supposed to be coming up on the third Sunday, but we flipped around. And my presentation, which I had advertised, which is going to be about the science of water, I'm not finished with it yet. And so I dug out one of my old presentations, updated it a little bit, and I thought that's what we'd talk about today. I think I first gave this during the pandemic, so a lot of people may not have seen it in any case. If this is old news to you and you find it boring, I apologize in advance. I do have a couple of updates, things that have happened in the past 2 or 3 years. So let's get started with scientific discoveries and wonders of the 21st century so far. Click. Says on. Does it have, let me see if the laser works. Yeah, laser's working. Hello, clicker. Oh, there we go. All right. Part one. Oh, and I shouldn't be banging on the podium. I tend to get quite enthusiastic about science, as most of you do, I'm sure. And my tendency is to bang on the podium, which drives the sound guy, who happens to be my husband, so I have to live with him, drives him crazy and apparently doesn't sound good. So I'll try to refrain from banging on the podium today. All right. Part one, science wonders. All right, we've got number one, the Higgs boson. That was discovered during this century. Might seem like old news to you, but we've had 24 years of this century. So the Higgs boson was one of the earliest really important scientific discoveries. It's the last particle predicted by what's known as the Standard Model of particle physics. Interactions with the Higgs field. So every particle in the universe, whether it's a photon associated with the electromagnetic field or other particles, are associated in our modeling of the way nature works. Our best model of the way nature works entails representing the particles of nature as excitations in a particle specific field. So the photons are excitations in the electromagnetic field, and electrons are excitations in the electron field. And then there's a top quark field and a bottom quark field and a muon field and a neutrino field and so on and so forth. So one of the interesting things about many of the particles of nature is that they have mass. And because they have mass, they move at a speed always less than the speed of light. So there's all kinds of consequences of having mass, such as inertia. And a big question in physics is, why do particles have mass? And the explanation for that is their interaction with the Higgs field. And just like every particle has a field, every field should have excitation states that correspond to particles. So we don't normally see Higgs particles zooming around in the universe, but the Higgs field permeates the universe, and excitations in that field should be manifest as Higgs particles. And that was discovered by the LHC back in 2008, something like that. I may have that date a little wrong. All right. Next, gravity waves. We've all heard about those. This is incorrect. I should have fixed this. This should actually be gravitational waves. There's a distinction. Gravity waves are large scale undulations in cloud formations and weather fronts. You see gravity waves. So meteorologists talk about gravity waves in cloud fronts. Gravitational waves are the physics thing that involve gravitational signals propagating through space. So apologies for the typo there. I was less smart 4 years ago than I am now. Right, and LIGO, Laser Interferometer, Great Gravitational Observatory. Several of these like this have been built around the world, and they do a great job of figuring out that catastrophic events in the universe that involve very large masses, like black holes colliding or neutron stars colliding, emit gravity waves. Neutrino science. This is still burgeoning, a burgeoning field. After finding the Higgs boson, physicists have gone back to take a closer look at what's known as a ghost particle. Colloquially, you can call it the ghost particle. One neutrino can go through something like 6 light years of lead before it has a significant chance of interacting with any other matter. So they just barely interact with anything. They don't bounce off of things. They don't emit light when they travel through space. They're very, very difficult to detect. And because of that difficulty, they're kind of hard to study. And a lot of physicists and experiments around the world have been concentrating on neutrino science, and that continues to this day. Let's see. Neutrinos in the standard model of physics, there's a representation of where they sit. The up-down quarks, the charm and strange quarks, the top and bottom quarks. Down at the bottom in the blue is electron, muon, and tau neutrino or fermions. So I'm sure you're all familiar with this. I don't need to go through it in detail. All right. Another big scientific discovery from the 21st century is that, remember, I don't know, when I was in college, and probably many of you in your history of listening to news and keeping up with science news, you've heard about the term junk DNA. And there's a lot of junk DNA in our genome and in the genomes of many other creatures on Earth and plants on Earth. Well, it turns out that a lot of what was previously considered junk is useful. And that's not terribly surprising because nature tends to be fairly economic. Natural selection tends to operate in a way that leads to an economic use of resources. So, having a bunch of extra junk in our DNA seemed a little strange, right? The copying machinery within our cells, the messenger RNA that carries out the transcription codons out of the nucleus and goes to the ribosomes, which manufacture proteins and whatnot. I mean, it's very complex machinery and it works really well, but why would it operate on a bunch of junk? And it turns out a lot of that isn't junk. A lot of times we have repeated codons, repeated gene sequences, and the old ideology that was prevalent in the 80s and 90s, perhaps up to the early 2000s, was one gene equals one protein, and even that has been thrown out. So you can have interspersed instructions for different genes, for different proteins, all within the same sort of gene segment that has a start and a stop codon. It gets really complicated, which you'd kind of expect. It's been 4.5 billion years or so of evolution, and nature has selected for all kinds of different mechanisms that lead to more optimal outcomes. And to us, that is insanely complex and difficult to untangle. And untangling DNA uncovered a lot of surprises that had to do with things other than the expression of proteins or the manufacture of proteins. So we found things like the level of expression, the amount of different proteins that are made in different times, that's relevant. Sometimes just the way the DNA folds up and compactifies within the nucleus, right? It's the DNA molecules in your cell are not strung out 6 meters long or whatever it is. They're not strung out in a large string. You couldn't fit that into your several hundreds of billions of cells, right? So the DNA in the nuclei of cells is smushed up and balled up. And one of the great discoveries is that the geometry of that ball of twine in the nucleus, the actual geometry of where it folds and how large the loops are and which loops are exposed at different times in different contexts, that's all really important for determining which messages are sent out of the nucleus. So some of the junk DNA just provides space to reel out more DNA strands so that it can bend and fold in a way that the machinery that reads the DNA is able to grab hold of and interpret. Really complicated stuff, and it's amazing. And a lot of it's just been discovered in the past 25 or so years. All right. Climate change, right? I was talking to a coworker the other day and I said how interesting it was that the narrative about climate change has changed over the years, especially among climate change skeptics who started off by saying, well, there's no way that us puny little humans can affect the whole planet. And then it went to, well, maybe we're having an effect, but it's much smaller than the effect of the solar cycles and other natural cycles, and we don't really have to worry about it. And then it became, well, maybe we have to worry about it, and maybe we're having an impact, but there's really not much we can do about it. And then they said, well, if you cut your CO2 emissions and methane emissions, and maybe we can do something about it. Well, okay, maybe we can do something about it, but China has to go first, right? So I like how well, like is perhaps not the right word, but it's interesting to see how the dialogue about climate change has changed over the past 20 years or so. And now the world seems to be taking it more seriously. Let's hope that it's better late than never. All right. And then they discovered water on the moon and on Mars. So that could be really important and helpful. For drinking water and for electrolysis or other means of separating the hydrogen from the oxygen and making really potent rocket fuel. So 2008, water on the moon. 2018, water discovered on Mars. Okay, part two, some special discoveries in biological and medical science. I already talked about the DNA thing, but this is getting into a little more of the weeds for biology. CRISPR-Cas9, the idea of gene editing and gene splicing. Mike gave a good talk about this a few years ago. You make a little template that matches up with a part of the DNA that you want to edit, and then you put the little scissor, metaphorically speaking, put little scissors on it that snip out the target part of the DNA, and then it's got a payload that replaces that target. Really complicated. Discover where you need to go, cut out the old one, put in the new one. That's what CRISPR-Cas9 does. And most recently, there was a treatment deployed as of December 8th. December 8th, the FDA approved a couple of different gene-related therapies for sickle cell anemia. And so they take out some of the cells that generate red blood cells. I think that's in your bone marrow. They take that out, they genetically modify it with CRISPR, they put it back in, and suddenly people who were having a lot of problems with sickle cell anemia and its consequences are showing dramatically improved health outcomes. So that's the first clinically approved major therapy for CRISPR-Cas9, and that's just a month ago. All right. I guess I do have little explanatory slides for these. Human genome DNA tests. How many of you have taken a at-home family history, healthcare, a genetic assessment thing, right? That has only been possible in the 21st century because of the decreasing cost of being able to sequence the human genome and discover different active genes and relate that to traits. AIDS treatment, right? AIDS is now a survivable, largely survivable disease if you get the right medications. There's even a prophylactic preventative available for AIDS. And that's a lot different than it was prior to the 21st century. Not to minimize its impact, its continuing devastating impact in a lot of poor countries that don't have access to the medicine or don't trust medicine, etc. All right, Neanderthal DNA. We found that all of us are a little bit Neanderthal. I'm not going to make the obvious joke because that would be disrespectful to our Neanderthal brethren. So that's pretty interesting, right? I even saw an article a week or so ago that said maybe Neanderthal and humans are so similar that it's not really appropriate to call them different species. That's interesting. And what do you call it? The cladists, the people in biology who decide what constitutes a species, anatomists and whatnot. They often argue with the biologist about what constitutes a species, but nature doesn't give a care, right? Nature is just a continuity, right? I mean, there's this wonderful thing, not Charles Darwin, the other biologist, Richard Dawkins, right? The other one. Um, he talks about in the desert around I think the Coachella Valley in California, there's a lizard species that kind of goes around that valley up in the foothills, and these foothills go for, I don't know, 500 miles, 1,000 miles, all the way around the valley, from kind of in a big horseshoe shape. And the lizard on this side of the horseshoe cannot successfully mate with the lizard on this side of the horseshoe, but it's a continuity through space of a species change. So normally we're used to thinking about a continuity or a continuity through time. You know, a species from long ago is different than a species today. Well, here's speciation through space, and we see the gradualism that ends up creating two different incompatible species. And he talks about another example about some birds that live in the Arctic and how the same phenomena happens. Anyway, Neanderthal DNA. We all have some, and it's still being studied. Is how important is it? What happened in the Neanderthals? Food pyramid changes, right? You know, they've turned the food pyramid upside down. It used to be they recommended a lot of carbohydrates when I was in school. Look what happened to me. And so the food triangle has been turned upside down this century, more aligned with science about what is healthy and nutritious. So that's really good news for our kids and grandkids. mRNA technology. When I first gave this talk, I think this was, I, I don't really remember whether it was 2019, 2021. It was certainly before the breakout of COVID, though. Or maybe right at the beginning. And it was certainly, in any case, before the mRNA vaccines that have been so helpful in helping us all survive the pandemic, those fortunate ones among us who have. So, and that's mRNA technology, and there's all kinds of efforts underway to use customized mRNA technology to treat specific cancers and other maladies. And it's fantastic. It's a completely brand new therapeutic method, and it's remarkable. And I think Mike has talked about that as well. So I don't have anything more to say about that. All right, technological wonders of this century. What do we got coming up here? We've got handheld computers, right? How many of you remember the Palm Pilot? I remember when I was in high school, a senior in high school, I had this little Radio Shack computer, and I could program it in BASIC, and it had a little LCD display. It was a portable little handheld computer, and I could write programs. Like one of my favorite programs to write, probably one of yours too, is a program to generate prime numbers, right? How many of you have done that, right? All of you, I'm sure. And so I programmed this little handheld computer to generate prime numbers, and I had this contest with my math teacher. He was probably the smartest teacher I've ever had. Maybe smarter even than some of the professors I had in college. It's a genius, man. He used group theory to figure out how to solve a Rubik's Cube, and then he applied the outcome of that theory to solve a Rubik's Cube. This is how smart this guy was, right? Anyway, he and I had a competition to see who could write the fastest prime number generating program. And, well, I'll leave it up to you to guess who won. Now we have handheld computers that we call smartphones, right? These things are amazing. You remember this? Have you seen the stories that if you took all of the technology in these smartphones, like its Atlas, its geographic atlas and road atlas, and its ability to play chess and to be a voice recorder and a video recorder and a camera and a calendar and index cards to keep names and addresses and on and on and on. If you went back to something like 1980 and bought and a flashlight and bought all these things independently, you'd have like $1.5 million you'd have to spend, and an answering machine, right? You'd have about $1.5 million you'd have to spend to get something like we can buy for a couple $100. So, like they say, the world's getting worse all the time, right? I don't believe it for several different reasons, but that's a whole other talk. So handheld computers, amazing. Flashlight, chess game, GPS, encyclopedia, calculator, timekeeper, library, camera, the whole thing. Television in your pocket. Flat screen, speaking of televisions, on your wall. Remember how much space in your living room a television had to take up? A whole wall or a whole corner. Well, now you can take up a whole wall, but it's only, that thick or that thick, whatever, right? So this is amazing technology and it's affordable. I remember seeing the first plasma TVs. I was down at Hammacher Schlemmer, or one of those fancy stores in downtown Chicago with a friend, and we saw this 42-inch television for $10,000, and it was flat and beautiful. Oh, I swooned. And now I've got like four of them in my house, right? So, and they're not $10,000. I haven't become suddenly wealthy. All right, internet and social media, right? Um, say no more. Everything you ever wanted to know about anything, and some things you don't want to know, and a lot of stuff that isn't even true. Digital photography and music, right? How many of you still use a film camera? Yep. How many of you still use cassette players? Right? Thanks to technology. Music synthesizers. I was in love with music synthesizers when I was a kid, and they were expensive and large. And now I've got a couple of MIDI control keyboards, and I plug it into my computer, and my computer does all the music synthesizing stuff. So I don't have to spend thousands of dollars on hardware. I can instead spend a few $100s on software. Green technology, right? This is all over the news for the whole decade or for the whole century so far. Solar and wind power, biofuels, etc. The cost of solar modules declines by 99.6% since 1976, and this only goes up to 2019. This data, right? And there have been breakthroughs ever since then. So solar power, in many contexts, and wind power is cheaper, economically cheaper than traditional fossil fuel based power. Amazing. What a world we live in. Let's do it. More of it faster. Um, Total energy generation over time. So total electricity generation, the top there, and 4,000 terawatts. This is for the US, by the way. And then you see the growing amount contributed by hydro, wind, solar, bio, and geothermal. Geothermal is something that is still relatively untapped, pardon the pun, and it's likely to grow this century. Also not represented on this graph is nuclear power, which I am a conservative proponent of. As long as it's done correctly and safely, it can really lead to a lot of improvements in standard of living and energy generation. Here it is normalized to 100%. It's something math geeks like to do. So this is 100% energy generation, and you see that renewables are now approaching 25% of our total energy generation in the United States. What this doesn't show is nuclear, which is also about 25%. So if you add nuclear onto these environmentally renewable, we now have over 50% of our power, or thereabouts, about 50% of our power being generated through environmentally more friendly ways that don't generate a lot of CO2 and pollutants. So making progress there. Electric cars, we've all seen the news about that. Social and societal wonders of this new century. All right, China modernizing. Steven Pinker wrote a book called The Better Angels of Our Nature. Michael Shermer, president of the Skeptic Society, wrote a similar book whose title is escaping me at the moment. Anyway, a lot of commentators and authors have written about how the human race in general, the standard of living, the quality of healthcare, the calories in a diet, many of these things have been increasing exponentially over the past 20, 25 years. And probably the single largest contributor to that is, some of you will probably sneer at me and not agree, but is globalization, right? When we offshore a lot of our manufacturing to previously disadvantaged countries and populations, suddenly they have gainful income. They can contribute to the global economy. And so notwithstanding some of the political and moral issues with the totalitarian regime in China, the people are human beings with families and lives and interests just like us, and their standard of living has been elevated tremendously by some of the advancements in manufacturing and transportation that have accompanied globalization. Something similar, although not quite as dramatic, is happening in India. Let's see. Gay rights, right? My husband and I got married the couple months after Trump was elected president of the United States because we were afraid that he'd stack the Supreme Court and gay marriage would be made illegal. We had been together for a long time prior to that, but that's what kind of tipped the balance for us. And gay rights became the law of the land. Those people, I was never particularly active in the gay rights movement. I've been more of a sort of a science enthusiast and science communicator. That's how I would identify myself primarily. I don't introduce myself or talk about my sexuality that often, but it's really cool that it's not a disparaged or illegal way to be a human being in our country. And that happened this century. Oh, that's me and my husband. This is my favorite picture of us, and it was taken by my friend John here in the front row. So. All right, the acceptance of evolution. This may be surprising, but the uh, the younger generations are almost as accepting of the theory of evolution and the science behind it as were the generations at the turn of the 20th century. What? So if you look at the presidential contest in about 1900, 1904, around that time frame, both candidates, I think it was William Jennings Bryan and maybe Theodore Roosevelt, something like that. What was that? McKinley? Okay. Both candidates liked to say that they are modern, that they're in favor of modernization and modern science, and they both supported the theory of evolution. Right? They explicitly said that. I'm on the leading edge of science. I love science. Science is going to drive our country into the next century, and part of this amazing science is the theory of evolution. That's the turn of the century, and then we kind of took a few steps back, at least in this country, for a while. But it's gaining traction again. Not because it's an ideology, but because it has evidence behind it, because it's science, because this is the way provably the world works. And that's what I love to see, right? It could be that there is magic in the world. It could be that magic spells and the spontaneous creation of living things, it could be that that happened in our universe, but we see no evidence for it. So I can't lend any credence to those kinds of points of view because the evidence is contrary. And we're doing a better job of convincing people around the world that that's true. Um, oh yeah, modern monetary theory. I haven't read as much about this as I intend to, but economics is one of the things I'm interested in. And there's this idea of modern monetary theory that envisions a different role for monetary policy, like how much money is printed and how much is taken out by buying government bonds. You know, the Federal Reserve and the Treasury, they have different levers they can pull to control the amount of money. And there's different kinds of money. There's M1, M2, right? If you get into macroeconomics, really fascinating. But you know, Keynesian economics and the Chicago School of Economics, they're sort of the traditional competing theories of macroeconomics, and there's this new idea around modern monetary theory. Essentially, it says anything you can do, if you've got the labor and the materials to do it, it really doesn't matter how much money it takes to accomplish it, as long as you've got the manufacturing and extractive capability to make it happen. So it's a kind of a different view on macroeconomics. And like I said, I haven't read as much about it as I intend to, but it's a new idea in macroeconomics from this century. Religiosity decreasing. This is very, I think it's helpful from a political standpoint and in terms of making progress against some of the challenges that we face globally within our societies. I happen to have a personal disposition vis-a-vis religion or traditional religion and supernaturalism, but that's when I'm using my humanist hat. As a science communicator, I try to be fairly neutral about it, but I recognize that people who espouse religious views and have lend credence to what I would call the supernatural, they're more likely to disregard some of the practical things we can do to make the world better. You know, pulling on the levers of nature and industry and economics to make a better world come true. So I think that decreasing religiosity, specifically as it relates to the policies that we implement about what we can do to make the world a better place, bundle all that together, and I'm happy to see religiosity diminishing. All right, update. Well, I'm getting through this faster than I thought. We'll have time for questions and whatnot. So this is new since I made the presentation. The James Webb Space Telescope and the Euclid Space Telescope and the Gaia survey. There's been the multiple mirror telescope, all kinds of innovations in astronomy that lead to better astrophysics. You know, how do stars work? How do galaxies work? What were the first stars like? What were the first galaxies like? How many of you saw the story from this past year-ish where they said there's this big galaxy found by the James Webb Space Telescope and it's bigger than scientists can explain? It's like this mystery about how galaxies got that big that early. Any of you remember seeing that story, right? Well, the initial results published by the scientists who work on the data provided by the James Webb Space Telescope, they they're beautiful people and they make these very precise statements typically about science and the conclusions you can draw from their science. And the early results from the James Webb Space Telescopes were almost always accompanied by a caveat that this is early data and we haven't fully deployed our spectrometers that look at the elemental composition of the light we're seeing, and we're still bringing some instruments on board and we still have some data to sort through. So these are preliminary. And then the press goes, "Oh my God, look, they found something amazing. Here it is. This is a bona fide fact, proven, incontrovertible." No, no, no. We still have some data to go through here. We're not sure yet. No, no, no. It's perfectly valid. right? So the press versus real science. Well, recently, like within the past couple of months, they've looked at some of the data related to these early giant galaxies and found that they're not giant galaxies. They're, in one case, it's four galaxies merging, which is exactly what is predicted by standard cosmological theory, that in the early universe, you've got a little galaxies, kind of like the Large and Small Magellanic Clouds, which they're thinking about renaming, which is a whole separate thing, because Magellan could apparently be a jerk, like you can't or I can't. I don't know. We're all perfect these days, right? Anyway, um, so they found these four little blobby galaxies coming together. Instead of being one big galaxy, it was coalescing small galaxies, and that comports with contemporary cosmological theory. Did not cause us to throw out the rule book about general relativity and the Big Bang and whatnot. So a lot of these discoveries progress apace, right? We're still making progress in understanding the universe, especially the early universe. One of the things they're looking for is the light of the first stars. So many times I think Mike have talked about the life cycle of stars, and it's one of my favorite topics. But the first stars in the universe, called population 3, um, not population 1, strangely. We're living with stars that are population 1 because they go backwards. It was population 1 are the newest stars. Population 2 are kind of old stars, and population 3, well, we don't even see them anywhere. They're long gone, right? Well, population 3 stars coalesced in a universe that had a vastly different chemical composition to the universe that gave rise to the population 2 and population 1 stars. Specifically, there was a lack of everything. There was hydrogen and there was helium and this tiny salting of some other elements, but not the enriched interstellar medium that we see today that's full of carbon. You've seen stories about detecting organic molecules in deep space and in the Orion Nebula and whatnot. That could not possibly have been true in the early universe until and unless somebody proves it otherwise. But right, consensus and all the data we've received so far rules out the possibility of any complex molecules or complex atoms beyond hydrogen and helium, mostly, but like 99.99999% of all the stuff that was made during the Big Bang was hydrogen and helium. 25% was helium and the rest was hydrogen. Anyway, so the first stars came to life, anthropomorphizing again, which I don't like to do. Anyway, they burst forth into brilliance in a universe where there were no metals. So everything beyond helium is a metal in astronomy. I've told you about that before. Metals are good at impeding the growth of stars because they're better. They're bigger atoms. They've got more electrons. They've got more ability to absorb light and heat. They've got more degrees of freedom. So especially as you get to the outer layers of the atmosphere of the star, and you can get diatomic, hydrogen. And anyway, the point is that the early stars didn't have metals in them to impede their growth, to absorb some of the energy, and so these were gigantic stars. Hypothetically, they were 200 times the mass of the sun, 500, perhaps 500 times the mass of a sun before the star gets so big that it it emits enough radiation to blast away the gas that's trying to coalesce onto it. Right? There's always a balancing act in physics when you've got a restoring force or other kinds of forces competing with each other. You've got the light pressure pushing out, you got gravity pulling in. At some point, there's a balance. Well, that balance point is much different in the early universe. And so the stars were hypothesized to be vastly bigger and to emit mostly ultraviolet light. But because of the redshift of due to the expansion of space within the universe and general relativity, that light is now infrared light. What started out as ultraviolet light is now infrared. And that is probably the biggest justification for building a giant infrared sensitive space telescope, which we now know as the James Webb Space Telescope. So that's one of its primary missions, is to look for the light signature of some of the earliest stars in the universe. And some scientists think they're getting close to being able to do that, looking at the light profiles of some of these early galaxies. Artificial intelligence. Jaw-dropping, right? Being able to talk to an artificially intelligent computer system and ask it English language or native language questions and have it reply with usually accurate and actionable and useful results. We've got I don't think there's one in this room, so I'm going to. Alexa. Okay, yeah, good. We don't have one around. If you've got your Alexas or your Siris or your Google Assistant and you talk to it and you ask it questions, I'm getting to that. Yeah, I'm talking about the ones that preceded 2022, 2023, right? You ask those devices questions, and I don't know, what was one the other day? I'll probably make it up, but it was something like, Alexa, who shot John F. Kennedy? And the answer is, to make beef stroganoff, you need 14. What? Right? You get those kinds of answers out of it. It doesn't do a great job of understanding your voice, and sometimes its answers are crazy. Anyway, with the revolution in artificial intelligence and what's called natural language processing and large language models, they've now created ChatGPT, but it's not the only one. Many companies are working on this, and there's many language models. And there's even language models you can run locally on a sufficiently powerful home computer. And you ask it questions about nearly anything you can imagine, and I don't know, 85% of the time it gives you more trustworthy results than some of these older voice assistants. They're still not perfect, right? This is brand new technology. Who knows what's going to happen in the next year, much less 10 or 20 years. There also, some companies are making autonomous robots that have a human-like facial expressions or are able to literally walk around and use their hands, and they've got pressure-sensitive fingers that can pick up an egg or smash a brick or whatever. And there's all kinds of potential non-military applications for these. And it's brand new. This is a new world that's being born before our very eyes. And image generation, if you ever wanted to be an artist and you imagined, I want a beautiful sunset and pelicans flying into the distance with mountains and, some jungle tree, you can just tell a computer to paint you a picture like that and it'll happen sometimes, kind of. But it's getting better, right? So the advances in artificial intelligence are roiling society, roiling the way economics works, manufacturing and copywriting and editing and plagiarism and other things. All right, brand new Ozempic started out as a diabetes treatment, and they found that as an unexpected side effect, it controlled appetite and incentivized. I'm not sure that's the right word. Encouraged weight loss. Encouraged your body to discard excess weight. Amazing drug that was just developed in the past few years. Not yet widely available to treat obesity itself, because there's a scarcity. Manufacturing is still trying to catch up with demand. Do you know where Ozempic comes from? Like the fundamental science that led to the discovery of this. Do you know what the root enzyme from Ozempic? Do you know what it's based on? Saliva of a Gila monster. Lizard spit. Yep. So this is this is an argument for the preservation of diversity, natural diversity, and biodiversity in our planet, among other things. You know, Gila monsters, they actually have venomous bite, right? Some people might say, well, they're venomous, they're kind of ugly and slimy, and they live in the desert, and who cares, right? Okay, so they're gone. Who cares? Maybe a billion diabetic people in the world care, right? So by preserving the natural ecosystems around us, we preserve a treasure trove of potentially useful biomedicines. And if you've seen a lot of David Attenborough narrated nature programs, like I have, and I absolutely love seeing them. If you've seen a lot of those, you know that sometimes it's useful to preserve the natural world just because it's awesome, right? So environmentalism and whatnot, and some of the social and economic and regulatory protections to help from deforestation and whatnot, and the science behind it. Like the Amazon rainforest is nurtured by dust blown out of the Sahara Desert, right? Did you know that? And it crosses the Atlantic Ocean, and that dust falls on the canopy of the Brazilian Amazon rainforest and provides nutrients. And so a desert supports perhaps the lushest ecosystem on Earth. Bizarre, right? The interconnectedness of our world and the fragility of it due to that interconnectedness is still something we continue to discover. And it's not all about exploiting nature. Sometimes it's about recognizing the beauty and the interconnectedness that may have unintended consequences if we mess with it. But it's not all good news, right? The people pictured here to various degrees are responsible for a rise in nationalism and ethnic kinds of orientations towards discrimination in their countries. Vladimir Putin and his government recently started a very harsh crackdown on the gay citizens, gay and lesbian citizens of Russia. I'm sorry, I didn't hear you. Minor invasion, yeah. Modi in India, there is growing evidence that he's implementing a program to turn India into a strictly Hindu state to the detriment of the Muslims and Christians and non-theists who live there. Each of these people pictured here has a story of oppression and totalitarianism, at least totalitarian tendencies for the person at the top left there. So we're not yet divorced from some of the reactionary tendencies that drive us apart and drive us to see fault in others and to try and harm those who are not like us. So we still have progress to make, not only in science, but in governance. And that's it. That's all I had prepared for so far the wonders of the 21st century. Thank you. All right, we've got 10 minutes or as long as you'd like for questions or reactions. Maybe you have a favorite. Oh, Dave, do we have the other microphone that we can? Yeah, if you don't speak into the microphone, you will not be heard on the video. So please wait for the microphone if you have a question or comment. Got one over here, Joanne.
Scott, I was thinking of Pinker's recent book on democracy versus authoritarianism. And, he just summarizes that really this is the time of flowering of democracy with kind of the idea of increased social development around the world has been promoting it. And there are more countries with democracy today than there have ever been. Whereas, of course, we're all concerned about towards authoritarianism and
Right.
yeah.
Yeah. And some of those, like India is the world's largest democracy, but still, with Modi in charge and some of the policies that are clearing through the legislature and the court system there, it's not behaving like a democracy, at least one that protects minority rights. That's one of the great things about, in principle, our country, is that there's always this tension between the will of the majority versus protecting the rights and interests of various minorities. And it's institutionalized in our law and in our constitution, and not all countries have that kind of protection for the individual with an acknowledgement of the rule of the majority. Are there questions, comments?
I have a couple of observations. The first one was on the technological innovations recently, and I have to say, for me personally, some 50 years after we landed astronauts on the moon and brought them safely back home, that we now have extension cords with flat plugs that go behind furniture.
Oh, that is an amazing accomplishment.
It is. It just, it's technology marches on. I love it.
Yeah.
And the other, but on a more serious note, you talked about the Chinese modernization and then the modern monetary theory. And I remember in high school and college that some of the basic economics courses would break down the economy into like a block diagram, and many of them showed labor as being this waste, like smoke going up the chimney. And now part of that modern monetary theory is that mysterious arrow called demand is inextricably linked to labor. There is that feedback loop that was missing for so many years, and I'm glad to see that become part of that, the discussion about economic theory.
Right. And there's one of the things I didn't mention was the notion of a universal basic income, which a few municipalities and I think one country in Scandinavia have tried. With as far as I know, I haven't researched this enough to make a definitive statement about what I've learned because I haven't learned a lot. But I think the universal basic income trials have been really big successes, for example. All right, another question, comment, observation?
Hi. First of all, I've never attended these before, and I want to thank you. You're very well spoken, and I really appreciate your presentation.
Thank you.
Most of the actual technical science went completely over my head, but I found it fascinating. When the humanist side, when you talk about the environment and these other things, you didn't touch on, and I don't know if it's related, the migration of peoples concerning like immigration with environment and changes in resources, and the other being the aging population across the world and the lack of the birth rate to sustain social structures, not only probably in our country, but in most developed countries.
Yeah.
And I just find that kind of interesting, and I don't know if that's something to thread in at some other point.
Yeah,
but thank you.
You're welcome. I'm happy to do this. This Science Sunday and the ability to talk about the thing in life that I care the most about, which is understanding how the world and the universe and people and economies and everything works. I love knowing all of that and being able to share it enriches my life, and I'm glad you're here. Anyway, 2 points. One is the migration of peoples and resource scarcity. Yeah, that's going to be a big challenge in the 21st century. I am hopeful that some of the science can't solve every problem. And, if there's a catastrophic volcanic eruption on the planet, or a meteorite hits, or there's a plague that we don't have a good treatment for, science can't, in a timely manner, solve every conceivable problem we have. But if we know about some of these problems far enough in advance, a combination of scientific innovation and government policy can help. And as a person, I guess you could describe me as having a progressive or liberal worldview on many things. I think people are people, regardless of what border encompasses the domicile of their family when they're born. And I think we should respect and cherish every person until they engage in behaviors that are harmful to others. And then if they, the more harmful, the more widespread the harm, I don't really have much empathy at all for the people, right? So I have a graduated scale of giving a darn, right? But especially poor people who are the subject of prejudice and a lot of immigration policies and a lot of negative rhetoric. Oh, they're poor, they're dirty, they're ugly. That's been around for hundreds of years, and it's just disheartening. So I think maybe social science and improving government policies and just basic human empathy might help us care for each other a little better across borders. But the other thing is science will have a role to play to this. We see all kinds of innovative solutions about making clean fuels, about making clean water, desalinization and whatnot in an ever more energy efficient way. And if we have more energy available to do more of this desalinization and some other things that are possible, I think it can lead to a better world for everybody. And we can overcome some of the challenges in geography. The other question was about, I'm sorry, aging populations. Right. Thank you for reminding me. So there's a YouTube personality I follow named Peter Zian. It starts with a Z. Z-I-A-N or Z-I-H-N, something like that. Peter Zian. And he's kind of a political theorist, macroeconomics guy. I don't agree with everything he says, but he has recognized these population bubbles in many countries. And one of the biggest population bubbles in any country in the world is China because of their one-child policy. And he and other uh, political economists are saying that we are right now witnessing the beginning of the unraveling of China as a great power in the world because of demographic and systemic economic challenges and the way the totalitarian government has fudged the numbers and tried to keep 100% employment. According to some estimates, China has the ability right now to house in comfortable living quarters something like between 3 and 4 billion people. That's much greater than the population of China. So they're housing overbuild. And what do you do when you want to protect your money, your capital from a volatile economic situation? One of the things you do is you invest in real estate. Real estate is historically a safe investment. Well, not in China, because in China, the supply far outstrips the demand, so the value of real estate is plummeting. At the same time, the demand for real estate is plummeting because the population is declining. So you've got all these socioeconomic factors at play that make for a challenging and complex future for a lot of countries. And I don't have time to go into a lot of it, but I recommend you look up Peter Zian and some other political economists and see what they have to say about it. But you put your finger on a big problem.
Okay, I have a lot of questions. I was taking notes.
Oh, good.
I'll try to be quick. Easy one. You were talking about the
program
acceptance.
today, so we can stay as long as we want, I think.
Okay. Oh, I see it. Acceptance. When you were talking about the increased acceptance of the theory of evolution. You said William Jennings Bryan and the other guy.
Yeah.
Were you talking about the Scopes monkey trial? Or?
No, I didn't talk about the scope. This was the Cross of Gold. He ran for president. Am I right about that? Yeah, William Jennings Bryan. Yeah.
And you said the other.
Yeah, who was McKinley apparently, not Roosevelt. Yeah, but my larger point wasn't about evolution in terms of the Scopes monkey trial. It was about the fact that both presidential candidates at the time openly espoused the advocacy for the theory of evolution.
Okay. Thank you. Going to decrease religiosity. Religiosity. Is that right?
Yeah.
In the U.S., you were saying that it was decreasing. What was the source on that from what you were reading?
So there have been various Pew research polls. You can find those on the web that talk about the increasing prevalence of what's called the nuns, N-O-N-E, nuns,
Oh,
and people who do not identify with a traditional religious affiliation, especially
Okay.
as you get into younger cohorts of our population.
okay. But Pew Research Center was also saying that, from what I was reading off the top of my head, in 2017 they were saying there was an increase in Islam, beliefs in Islam in the U.S.
Okay, that sounds reasonable.
But okay,
I would be interested in see the population distribution of that. And by the way, I don't claim to be an expert on any of this.
Oh.
I do my best to relate the data that I've found, but if I'm wrong, I'm wrong. So,
Okay.
and things have changed, right? Since Steven Pinker wrote his book about the better angels of our nature and the increase in democracies, right? Russia was a democracy for a while after the fall of the Soviet Union, right? China is ostensibly a democracy. India is the world's largest democracy, and yet some of the most oppressive totalitarian policies we see come out of these ostensibly democratic countries. So saying it's democratic is not necessarily indicating there's a. Can you hold a couple of your questions? We got another couple. Okay.
So if this question is not relating to your presentation.
Can you hold it a little closer to you?
Sure. Is that better?
Yeah.
Okay. This question is not relating to your presentation. And so if it's not a fair question, I understand that. But it's more wondering if you or anyone in the room has some resource ideas for my family. We're looking at some environmental debates in our family, such as is silicone better than plastic? Should we really be rinsing all these recyclables when my college-educated kids insist it is not being recycled? And these are raging debates in my family where a quick Google search always seems to answer the question, by a company that's selling silicone products or that's selling the,
Right.
recycling bin. And I am emphasizing to my children that this is not a sufficient answer to our educated debate. Your comment on science really impressed me, using it to make good decisions. I have been looking for several months for a resource that's got a little bit more of a environmental or a consumer or residential slant to it to help us inform our decisions. And I've come up with nothing but the quick Google search that my children rely on.
Yeah.
Do you know, or do you have any recommendations for any science-based resource, that would help us?
Yep. So I bet there's some people in the room that know this even better than I
As
do.
a chemist who's been involved with plastics for 50 years, silicones are just another form of plastic.
All right. So there are. I think Mike. I'm sorry. I'm sad that Mike Winter isn't here with us today because I think he could answer this more readily than me. Yeah. The gentleman who's talking to you right now, I think, is also pretty well informed about some of the local consumer advocacy and science-based programs. I myself. Yeah. Go ahead.
One of the of interest, you mentioned neutrino science. The lead in the world right now is Fermilab in
Right.
terms of neutrino science. And Argonne National Laboratory, the other close by facility, has done stuff on HIV and helped develop the medicines that are available. So a lot of what we have locally is really significant in terms of science and the development of research and development in the United States.
Right.
And what source I mentioned back there to the one behind me was Consumers Reports.
Yeah.
It doesn't answer every question, but does a pretty reasonable job based on science and stuff like that. But there is a lot going on. And I used to work for the Department of Energy in terms of science. Supercomputers now, the most sophisticated, fastest, best computers are being developed through a number of national laboratories: Argonne, Oak Ridge National Laboratory, Lawrence Livermore National Laboratory, Lawrence Berkeley National Laboratory. So a lot of the science that's pushing the future is really being done by facilities in the United States, in particular too here in the local area.
Yeah. So back to your question about resources, I think that Wikipedia is a better source than a lot of corporate pushed messaging. Wikipedia is surprisingly reliable. You'll see disparaging comments about it. Go to primary sources, right? But Wikipedia does a pretty good, if not excellent job of referencing primary sources in the citations section of various articles. And if you want to understand recycling, plastics recycling, find the Wikipedia page on it. I know there's some kind of documentary that got produced in the past few years talking about recycling as kind of a sham, that a lot of what we believe to be eventually recycled material ends up in landfills because the world just doesn't have a good way of requires a lot of hand sorting and washing, and there's just not a lot of incentive for people to spend time doing that. They don't have good machine. You can put a magnet over something and get the steel out of it, and you can run certain chemicals through it and get maybe some wood pulp out of it or something like that. But it's disappointing how little of what we think we're recycling ends up actually recycled, according to some sources. Joanne,
yes, Waste Management is one of those companies, of course, that's heavily involved with this, and they actually have tours where they show you what's going on, and it's striking.
That might be fun. Take that tour.
It's just almost impossible to separate almost everything. They can separate paper, they can separate iron. It's harder to separate aluminum, and when you get down to the plastics, they just get dumped.
Yeah.
And what do you do with your computers? Guess what? They're going to landfills. They are not being regenerated. There's nothing being regenerated whatsoever. Occasionally, someone will put some acid in, pull some silver out, but almost all of it is just dumped. And a lot of it's going into places like China.
Yep. She had a follow-up. Could you wait for the microphone?
Oh, coming. Mike, I have set out like on a 3-month quest to find out if in Bolingbrook through Groot, are we really recycling?
Oh,
My
great.
kids keep telling me, stop rinsing everything, Mom. There's going to be water wars. And you're using water to rinse all the stuff that's going in the landfill. And I have not gotten an answer yet. But if I do, I intend to keep coming and I'll let everyone know. But
Great.
it's harder to get an answer to that. I've contacted local people. Really, I don't get an answer on the topic.
Yeah.
So.
I'm sorry I don't have off the top of my head. But if you said you'll keep coming back, when Mike is here in 2 weeks, Mike Winters, the other sort of co-host of Science Sunday, I think he has better knowledge of some of these consumer active groups than I do. So bring your question back. All right. We are over time. I'll stick around if anybody has any other questions or comments, but thank you for coming to Science Sunday. We hope to see you in 2 weeks. Next Wednesday evening, the Humanist Group, which I have the fortune to lead, we're having a discussion here in this room at 7:30 p.m. The discussion is, where does morality come from, especially in the context of not believing in a supernatural higher power? So where do we get our morality? And that'll be the first of a couple of discussions about morality that I want to host here. So see you then. See you next Science Sunday. See you around. Good to see you this year. Take care, everybody.